Hello everybody, my name is Sam Schmidt, a student in the Wouldering Lab at MSU. Today I want to talk about this paper, Prompting Fab Yeast Surface Display Efficiency by ER Retention and Molecular Chaperone Co-expression. So in this paper, the authors try and improve display efficiency of difficult fabs on yeast surface display. So they do that with three different techniques. First is trying a divergent promoter, wherein they have the light chain and the heavy chain expressed separately, and then have them brought to the ER where they get folded and displayed. And so this first figure here is just showing that they are in fact having the light chains and the heavy chains created, and that they're being brought to the surface of the yeast and displayed. Next, they wanted to check and make sure that their fabs were functional. So they picked this D2B7 and checked binding at nanomolar concentrations. And so they found, pretty decent binding of a already well-established clone, and concluded that their system was indeed creating functional fabs. Not satisfied with this, because it's not that novel, the authors tried the inclusion of a molecular chaperone, either CAR2P or PDI1P, and found that there was a decrease in the total number of fabs displayed on the yeast cell surface, but there was an increase in the percentage of functional fabs displayed. The authors also hypothesized that as folding takes place in the endoplasmic reticulum by using ER retention sequences, they could also increase the efficiency of the yeast surface display. And so this is increasing retention strength, and as we see with the molecular chaperones, as we increase retention time, we get an increase in display efficiency or functional efficiency, but we get a decrease in the total number of fabs displayed. So while more of them are functional and folded properly, there aren't as many as there are without these retention sequences. And finally, the authors wanted to check and see if they could find, if they could use the system to determine to use it for antibody engineering and find one sequence in a large number, or somewhat large number of non-functional sequences, or sequences that they don't want. And after 7 to 9 rounds of sorting, the authors ended up finding this clone that they had been looking for initially, and concluded that their system could be used, but they did note the trade-offs between total display of fabs and increase in fab efficiency. Thank you.